All right, so we're getting to 13.5, and we're talking about weighted averages. And by the end of this one, you should be able to determine the weighted average of a couple points on a line or more than a couple points, and explain how the weighted average moves when you move the points that you're talking about. Okay, so let's start off kind of with a visual explaining what a weighted average is, and we're going to use remembering the ratio lines. We're splitting things up with the ratio. So we have 2 to 10. Okay, so we have a line that's 2 to 10 long, and let's say we're going to partition this line into a ratio of 1 to 3 from A to B. Okay, so ratio of A to B, and we're gonna mark it at, point M is a ratio of 1 to 3. So that means that there's gonna be how many parts? There's gonna be 4 parts. Okay, so that means that we're gonna partition this thing into 4 equal parts. So there's 10 parts of this, or 8 parts of this from 2 to 10. So I'm going to dice that up into things that are about 2 long each. Okay, so there's 4 total, and then if it's going to be a 1/3, that means 1 of 4 of them. I'll call that point M. Right, that results in a 1. Results in a 1 to 4. Grab a highlighter. So a 1 to 3 ratio. That results in a 1 to 3 ratio. Okay, on this line, the ratio of AM. So we'll say like the man, where are all my pens? Oh, here. All right, so we'll say that the ratio here of AM, call this AM right here, AM to AB, the ratio of, we'll call that AM to MB is 1 to 3, right? That's the ratio of that. Okay. So now let's envision here that this is a scale here. Okay, this is a teeter-totter. Where'd my thing go? Okay, and I wanted to weigh this right here on this teeter-totter. Okay, this is my point of my teeter-totter point, called point T. Okay, I called that point T. Right, and I'm like, all right, well, what is the value, or what is the average of point T here? Okay, well, I have 4 this, I have 2 that way, I have 2 that way, so the average would be, well, 2 units, and 2 units, so 2 plus 2 divided by 2, my average equals 2. Well, that makes sense. Right, so my point would be 2, which is indeed, it is 2. My point here for point T is 2. Okay, well, that makes sense. It's my average of the 2 points, which is indeed my midpoint. It's my midpoint. Okay, but now say that I move this. Let's say that I move it to, erase this. I move my scale, or my teeter-totter, and I move it to over here. Right? Now it's way off balance. Right? This side, right, is going to need a lot more weight in order to counterweight this, right? Because this is just more of it. Okay, and there's 4 segments, right? So in order to make this all weighted correctly, right, this is going to be 3/4 of the whole line segment times AM, and this is going to have to be 1/4 of the whole of, sorry, not AM, of AB, of the whole line segment of AB, right? And this is going to have to be 3/4 or 1/4 of AB, right? So this is, if AB is 1, 2, 3, 4, which it is, right? That means that AB is 3. Right, that this line segment is going to be 3 of the weight, and MB is only going to be 1/4 of 4, which is going to be 1 of the weight, which is 4. The average is going to be 4 of that. Okay, so that seems a little bit straightforward with a single line, but what if we have with a single, like just one coordinate, just an x coordinate, but what if we have double coordinates? Okay, so let me pause this and draw a line with 2 coordinates. Okay, so here is a line GH, and we're going to partition it in a 3-to-1 ratio. That means that it's going to be 3 parts G to 1 part H. Right, so the partition is going to be closest to H because 3 is on the big side of H. All right, but we're not going to do it directly on GH. We have to partition the X part of H and the G part of H, or in the Y part of GH. All right, so we're going to do that like this. Okay, so I'm going to make my X part like this. It's going to be green. X part is green. Okay, maybe it's a little hard to see, but this is my X part. All right. And my 3-to-1 ratio is actually going to break this thing up into 4 pieces. So 3-to-1, 3-to-1, therefore 4 pieces. Okay? So my fraction is going to be, I have 4/4 to divvy out. Okay? Now 3/4 of that is going to be on the G side. 1/4 of that is going to be on the H side. Okay? And my X coordinate for G is 2. So 2. And 3/4 of that is going to be so remember, whatever it's closest to gets the bigger number. Okay? So my partition is going to be closest to H. Right? So since this is closest to H, this is the farthest away from my partition, right? It gets the smallest number. Right? So this is going to be 2 times 1/4. Okay, that's my X value. So 2 times 1/4 equals 1/2. Equals 1/2. Okay, so that's for H. That's for my G value. My G value is going to be that, and then for my H value, it's going to be 2. I'm sorry, my A is going to be it's going to be 10, because that's what it starts at. This is a 10, so this is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 10 times the rest is 3/4. 3/4, which is 10 times 3/4 equals 7.5. which equals 7.5 equals 7 and a half. Okay, so now I need to add these two together, and I get 8. Because 7 and 1/2 plus a half equals 8. So this is going to be the x value. That's going to be the x value for my partition. It's going to be 8. All right, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8. That's going to be my x value for my partition. Okay? So it's probably going to end up right there. The y value is going to be the same thing. Okay? My y value for G, is negative 2. Negative 2. And it's going to be 1/4 of my weighted average, because it's farthest away from my partition. It's on the heavy side, right? So it's going to be the smallest. Okay, so it gets the least amount of the weight that I need to add to it, right? So this is going to be negative 2 times 1/4 is negative 1/2. Okay, this is going to be 3/4 times 1, which equals 3/4. Okay, so 3/4 minus a half equals, that is 2/4. That's going to be 1/4. So that's going to be 1/4. So, which is looks like right there. So this is my point. That is going to be 3. That's going to partition this out of 1, 2, 3 to 1. So if I look at this, look at my x value, that's really what gives it away. 3. This is going to be 1, 2, 3 to 1. That's my 3 to 1 ratio. And my point here, if I write it, my point will be 3/4 for my y value and 8 for my x value. 8 for my x value. Okay? So that is how you do that. Right? So to summarize it, right, whatever point, right, so you figure out what is going to be closest, whatever your partition is going to be closest to, by whatever the smaller number in your ratio is. It's going to be closest to that. Okay? Then you figure out how many pieces by adding your ratio numbers. Okay? Then the one that's going to be closest to gets the most number of pieces. Right? This one got 3 of the 4 pieces because it's closest to, it needs most of the weight to balance the line. Right? Remember, from my line, it needs to balance, the scale needs to be balanced. Right? This is heavier than that. Right? So it needed more of the weight to balance this. Okay, so I needed to multiply both my x and my y values by the bigger part of the fraction, by the 3/4. Okay, by the 3/4. And the smaller part of the fraction by the 1/2. That was counterintuitive to me when I first learned this. So just remember, I need to balance the scale. Okay, the scale point, the pivot point's right here, right? So this section needs more of the weight, the bigger part of the fraction. Okay, so hopefully this helps you guys. If you use that process, it shouldn't be too hard. Okay.